Hello everyone, my name is Vignesh from Vellore Institute of Technology, registration number 22BCT 0001, and with me on this project is B. Satvik, registration number 22BCT 0273. Our project is titled Demonstration of EEG Functioning with Machine Learning Based Prediction of Simple Motor Imagery. The aim of this project is to demonstrate how EEG signals, that is, electrical activity from the brain, can be captured, processed, and interpreted using machine learning to predict simple motor imagery, left hand or right hand movements. This project essentially bridges between neuroscience, signal processing, and machine learning, giving a glimpse of how BCI work in practice. So, we used EEG motor movement imagery dataset. Let me show you the dataset from the Physionet website. So this is the dataset in EDF format. It is containing multiple EEG channel signals collected at a sampling rate of 160 Hz. I will be sharing the link of this dataset in the description for your reference. So now let me show you the simple animation of how electrodes are placed inside the brain. Here I am going to show 3D visualization of electrode placement. Let me run the script, loading the EEG BCA dataset. Okay, the animation you can see here is a basic 3D animation with standard EEG 1020 system. So the spheres or the circles here represents electrodes that record voltage potential at different locations of the scalp. The animation dynamically highlights the active electrodes, simulating how EEG signals fluctuate during motor imagery. You can see that when brain activity increases, certain regions, electrodes pulse in color, showing higher signal energy. This kind of visualization helps us to understand how different brain regions respond to motor imagination tasks. So now let's look into our trained machine learning model to classify these signals. So right here is the script of the machine learning code that we have used to create our model. So we first pre-process the raw data and uh, we have made it into 7 and 35 Hertz to remove noise and focus on motor related rhythms. Then we extracted features using CSP and LDA. As you can see, we are using a pipeline to schedule the tasks. CSP will be used to extract the features from the dataset, and uh, LDA will be used to differentiate between different motor activities, say left hand and right hand. So you can see clearly the code. After this, let me show you the Flask server, which is used as a web server for our Python ML model. This is the Flask server that I have created for this purpose. This Flask server is used to receive the EDF files, and it will be passing on a prediction server, and that is the ML model. After training the ML model, that is EEG.py, we have saved the results into a joblib file. As you can see, CSP LDA joblib. This is the file which has the pre-trained weights of the model. And now let me show you while running the code. So, okay, I'll be running the Python code over here. This is the Flask server which will receive the EDF images. So after that, we have also made a 3D model to make the output more intuitive. We connect the ML predictions to the 3D animation built using 3JS. Let me show you that as well. So this is the file which contains 3JS. In the source file, this is the main part where we use 3JS to simulate a Y-bot, the pre-made model which is available on the internet, and we will use this to uh, make the robot move its hands based on the predictions done by our Flask server. So let me run this as well. So okay, now we can uh, clearly see the robot, the Y-bot we say it, in the screen, and we can see a small option saying to choose a file to upload, and here we can choose any file. So I have downloaded two of the files, like one associated with the left hand and one with the right hand. So let me keep the left hand imagery EDF file. This was downloaded from the same dataset that I have shown you earlier. So as you can see, the left hand of the Vibot has just bent down and came up. And if we change the file to the right hand imagery, let us see. I have now uploaded the right hand imagery, which after prediction will give yield the result. As you can see, the Vibot is moving its right hand. So Uh, so in this whole project, I was mainly responsible for collecting and pre-processing the dataset, developing the ML model, and designing the Flask API for receiving and pre-processing EEG data. My teammate B. Satvik contributed to the front-end integration, 3D visualization of the electrodes, what you have seen earlier, and overall UI design for the demonstration. And he is also responsible for the documentation of the whole project. Together, we combined signal processing, machine learning, and web visualization components into a complete interactive demo. So, in conclusion, our project successfully demonstrates how EEG signals can be analyzed using machine learning to predict motor imagery, and how such predictions can be visualized in an interactive 3D environment. This forms a foundational step towards BCA systems that can aid in neurorehabilitation and assistive technologies. And human machine interaction is well demonstrated in this whole video. So thank you for watching.